Welcome, everyone, to the second Tech and Tie-Dye Community Meetup. We've got a very cool demo, which is a collaboration between LSD and our partners, DigiCloud Africa, Google, and iOCO Cloud Services. And we'd like to thank them all for taking part in this and, agreeing to help us show off this amazing technology. Really, thank you all for attending. So we're going to look at Google Anthos and the LSD cloud native story. So I'm going to hand over to DJ, Sizwe, and Jules now.
Hi, so I'm DJ. I work at LSD, and today I'm going to be talking to you guys about the LSD cloud native trip. What's interesting about it is, we've been doing this for quite a long time, and we've actually been doing all of these different components, and now we've sort of come to realize that if we can actually put it together in this sort of coherent trip, which is pretty cool. Okay, cool. So whenever we start the conversation, we obviously want to talk about LSD, what we believe, and why we do what we do. And for people who know LSD, well, they'll know what sort of company we are. We are a very open business. We're open everything, and from openness, that is what drives innovation within businesses. We're, as Steph was saying earlier, we're a company that sort of come to realize that we don't want to be limited to areas. So we want to work from anywhere to anywhere, which is sort of why, we're sort of like a cloud business doing things in a cloud way. If, we've got SSH and VPN, we can pretty much get the job done. From a, zero software cost, like software, we can see it sort of trending towards zero, and more large enterprises now even making use of community-based software, and that lends itself to getting high return on investment, succeeding fast. There's a lot of innovation happening in that market space as well. We're a neutral business, so we don't like the idea of being swayed because of a specific vendor or something like that. We choose what's right for the business, and that really is sort of the way we want to do. We're a very sort of purpose-driven business that does things in that manner. Freedom, everything we do is about freedom. It's not something that we don't want to lock people in. We like the idea of coming, helping, and giving you the tools. So even if at some point you don't want to work with LSD, you can go and do and follow this process somewhere else. We then have sort of get everything, which is everything is code, and this is sort of way that we work as a business is everything has become code, and everything is put into this sort of source of truth that you work from. And that's really something that we feel very strongly is a way for agility and being able to scale quickly, and that is what you want to do. So that sort of is where we find ourselves working on. So there's many paths to enlightenment. Be sure you take the one with the heart. So that there's 2 points here that's really important. Is we are a purpose-driven business. We feel very strongly about that, but there's also the fact that there are many paths, which is sort of what we're representing here. Is like at the road up the mountain, there's many paths. They're hard, but there's no wrong path. You're going to get to the top anyway. And each of these sort of circles will represent something going forward in this presentation, and you'll see them. So, when you start your trip, you can see this lady's very confused, and there's a lot of complexity with when it comes to starting this sort of cloud native journey. There's a lack of skill that means that you don't want to put the effort in. There's legacy, how does that fit in? Do we move it? Do we replace it? Do we lift and shift? Do we re-architecture? There's like all these different components that needs to be taken into account. And, sometimes it will take long to get a good solution. And so we don't want to start because the journey will take too long. So we really want to understand where you are, what the possibilities are that you want to achieve. We want to come with experience and want to lower the time for you to actually get something that works. And we've got a point here around option fatigue. There's so many things in the market at the moment. If we look at cloud native, just in one segment, there's 4 or 5 or 6 different tools to choose from. So how do you make that decision? And that's sort of where we want to help out. Then the start of this this trip, you always have to start with a map. And the trip map is where we sit down, we understand where you are currently. We want to look at what the gap is from where you are to where you want to go. We want to prove to you that we are able to help you and partner with you to become sort of a leader and help you to achieve the goals that you want to achieve, and put together that map for you. It's sort of like this image where every component on this cloud native journey is like a complex rock that's different in very specific ways, but we can find a way to sort of shape them and work with them so they all stack up together to accomplish the goal that you needed to accomplish. So when we start, so the next part of the trip, whenever we're talking about cloud native, it always starts with containers, and LSDcontainer is LSD's solution in that space. And what LSDcontainer is a fully managed, deployed container platform that's based on Kubernetes. We don't limit what sort of Kubernetes. You've got this is now where the option fatigue comes in. You've got OpenShift, you've got Rancher, you've got Anthos, GKE. There's a lot of different solutions there. But what does it give you? From containers, you get repeatability, you get that stability, and you also get the fact that you are very agile and you can scale up and scale down very quickly. It also gives you that hybrid and multi-cloud model out the bat, which is really amazing. So once you've got containers, and you can do this before or after, again, the trip is flexible. But automation, when we're looking at automation, there's two components to it. This one specifically talks around the infrastructure and making sure that you can put down infrastructure in a repeatable way. You've got a source of truth where you know exactly what you're delivering. You know that how you can change it. You're putting this through your sort of your Git pipelines. You get cloud ready. And then from an LSD perspective, we have it as a service model, which is basically coming in and automating for you. Obviously, now we've got infrastructure automation. The next one is what we call LSD DevOps, which is the development automation. This is where we want to be able to put your code in Git, run it through automated testing. You get your consistency and your compliance. Again, we've got a service that will help you actually deploy this for your developers, putting down a single CI/CD pipeline that everyone can use. You know exactly how the processes follow, and it integrates into the different components to make sure that it works as you would expect it to work. Obviously, now that you've got your containers, you've got your automation, you're releasing automatically. If you're running in containers or any form of microservice, you've got a lot of components all over the place, and that's where LSD Observe comes in. It's a place where we can get all of the information, the metrics, and get a single pane of glass view of all the services that you're currently running. And that becomes crucially important because there's so many. You want to know if I look at one place, I know exactly where are my containers. I want to know what are the resources they're using. Are they getting close to running out? And correlation between them, so that we know if one thing happens on this side, how will it affect something on the other side. LSD data is where we put down a elastic and confluent stream of data that you can start ingesting data from all over the place and start getting really powerful data. Annette was talking about when you're starting out, you don't have a lot of good data, and having good data to be able to get insight into your business and be able to make decisions based on the information that you have at hand becomes really crucial. So we want to be able to build that out and get it from everywhere. It's really important that if you've got all these different data sources, to get it from a single place, get it into a single place, start working at it, and then produce it back to you in a visual way that will make sense to you to make decisions on that. Security also becomes very important. We talk about DevOps, then we've got DevSecOps. The security becomes a very crucial part of this. Everyone is busy talking about it. There's a lot of things happening around security, hacking, and people not being able to keep their information secure. So that is a very crucial part to this. This is where we've got your credential and secrets management. This can be either containers or VMs or whatever. You use a vault where we can basically put all the information in a place where no one can access it. Make sure that it's your identity, and you've got authentication. You've got your role-based access control and your cloud native security powered by your DevSecOps. And the last component comes into is LSD integration. Now, this is where you've got your, we want to be able to have all of the different components meshed together in a service mesh. We want to be able to manage and expose REST endpoints, and we want to be able to intelligently load balance between your containers. So the integration is where you use your tools like APIs and service meshes to be able to get a connection between all of the different components together in a single way. And then once you've sort of walked this path, then then you get to this end nirvana. And if you do not change direction, you may end up where you are heading. So that's quite a poignant phrase that we came across. And you get to this nirvana, this end result where it's just everything sort of fits together. But the point we wanted to make that before enlightenment, you chop wood and you carry water, but after it, you do exactly the same thing. So there's a bit of the same thing happening again, but it is a road, it is a path that you're walking up. And I think that LSD can, we've put together the story, and we feel like there's some really cool things that can come from it. So yeah, I went quite quickly there to give time for the Google guys.
So guys, I don't have a presentation for you. This is your opportunity to rest your eyes, because when Julian comes on a little bit later, they're going to go back to work. I am going to work your ears though. I'm from DigiCloud Africa. We're a new player in the cloud space, specifically in the GCP, Google's cloud. We're Google's enablement partner for Africa, which is to say we help manage Google's partner network with everything regards to GCP and G Suite. It's a very exciting space to be in, because it is the right time for businesses to make their digital transformation and sort of reinvent themselves to some degree around presenting in this new digital market. And with that, Deon, you were saying that there's multiple paths up the mountain, and there's no right path, but I'd like to believe there's the best path. The path that gets you there without you getting all sweaty and flustered. You get there and you still look good, right? And I think that's what GCP actually represents for a cloud journey. So one of the challenges that we face as DigiCloud is that people don't really know that Google has a cloud to begin with. It's a little bit of a very well-kept secret. And we're really bringing that information to the people that, hey, there is such a thing as a Google Cloud, and it happens to be quite amazing. It actually, and this is for me, my favorite thing about the Google's cloud in comparison to all, and we're not going to want to get into a comparison blow by blow, but my favorite thing about Google's cloud is that I think the engineer experience is superior. I'm an engineer. I want to play in a space, like it's like choosing your IDE. IDEs with clutter, with too many choices, can tend to overwhelm someone. And I think Google has done a great job of rationalizing everything into this console, which you'll get to see a little bit later, that is very engineer friendly. And I think that's where we're going to win quite a few battles for enterprises, because architecture, as we know, can get very cluttered, can get very complex and bloated. So having a console that allows you to bring all of these things, see them in one place, is really a very powerful thing. And GCP's console is very powerful in that sense. I really urge almost everybody, technical or not, get in there, have a look. There's interesting things for everyone. You scroll down to the bottom and you get to see the machine learning and the data wrangling APIs. That's some really powerful stuff that doesn't necessarily require the most technical person in the universe. Another amazing thing about Google's cloud is its network. That's its actual superpower, it seems. When you actually look at the network that Google has built, of which it hosts 30% of internet traffic in the world, Google's network. And that's actually one of the powers that when you have a workload running in Google, it has, sort of the most amazing connectivity, and you have the most amazing control around who can talk to your machine and how easily it can reach out. And all of this is happening over the Google's dedicated network. So you're not competing with all sorts of randoms. Google is going to guarantee your ability to communicate, which is quite lovely as well. And they are recently, there's a lot of debate around which of the cloud guys are investing in Africa in any real sense. Yes, some of our competitors are making a big show of, setting up data centers, and it's all well and good. We love that. Bring investment into Africa. But I think one of the more significant investments that we're actually seeing in Africa is this Equiano cable that Google is building that is going to land in Cape Town in 2021. It's actually quite amazing the impact it's going to have on Africa's connectivity. And that's not just for cloud, but that's for everything. Anything will be able to access, and as a continent, we will be upgraded from a connectivity perspective. And I think that's quite amazing. That's the number I think is somewhere around $3 billion in terms of laying down that pipe. So it's a very significant investment. And we like to believe that at the end of that, where the pipe is built, the connectivity is there, the question of a data center then only really comes into play for Google when the connectivity is there. And then we can start having that conversation about data centers. And that's coming on the horizon relatively soon. And then again, one last superpower that Google really is just shining as a head above the rest, above everyone, is in that space of AI and machine learning frameworks, the open source ones in particular. They're playing very open cards around how we can all leverage AI and machine learning to really build insights quickly, insights that can help you make decisions as a business in real time, not 3 years later after the event. In real time, you're getting information and you're making decisions based on that information. One of our most popular products with regards to that is BigQuery data warehousing. A lot of companies are finding it incredibly easy to manage the large amounts of data that they're generating as they operate in BigQuery. It's just a very clean solution, which speaks to a lot of what Google is doing. They just simplify and clean and stick to what you're trying to solve for. Which brings us now to Anthos. And Anthos is a bit of a game changer. No, not a bit of a game changer. It's a lot of a game changer. It is the enterprise's view of its IT footprint. I mean, we've all lost a server at some stage, right? Back in the day, because managing IT enterprise architecture is hard, guys. It's not something that's to be taken lightly. I've seen fistfights in offices over, all sorts of things, blaming each other around failures, around, oh no, it was the networking team that didn't get this right, and that's why we can't find this issue and we can't solve for X and blah blah blah. Where's this latency coming from? And that is all because there's all of these different solutions that are playing together, but it's very hard to get that larger overview. And Anthos is bringing that to enterprises. It's actually quite amazing for me, because having grown up in this industry without that, I know what they're solving for, and I'm incredibly excited because I think enterprises will get the agility that they lost when they scaled, when they have that full view again, right? And that's where I think Anthos is really just again solving a very big problem. And what it also represents, Anthos represents a different shift, a small shift in focus for Google Cloud, where Google's cloud grew out of them supporting their own apps on their own cloud, eating their own dog food, so to speak. And I think that's also why it's actually a quality product, because they're eating their own dog food, and they know that the engineer experience is very, very important. But with this enterprise focus that Thomas Kurian, the new CEO of Cloud, is bringing, we are actually giving attention to enterprises and saying, guys, you guys want to be able to scale, but you want to be able to maintain a simple and clean and agile architecture. Here is the toolings for you. Yes. And it's all part of this modernization journey, because there's just been this journey where we virtualized, and then we got to the point where we containerized, and now it seems the abstraction that people are working with is just workload. No, just move your workload, which is, you know, very entertaining for me, because it's a nice abstraction. I like the abstraction of a movable workload that can move anywhere, because Anthos is supporting that type of thing, where a workload is a workload. You want to run it in Amazon, go and run it in Amazon. You want to run it in Cape Town, run it in Cape Town. The choices are yours. It's a workload. You can control it from this one panel, right? And I think one of the things that it actually does solve for is this data center issue that, you know, various enterprises may actually face in a very real way, where they've got sensitive data that they really want to keep local, or they're worried about various latency issues. Then they want to keep a local data center, except they don't want that to then be outside of their cloud solution, because then that adds overhead in trying to manage it and then integrate it back, right? So Anthos then allows you to then run a local workload that keep that same abstraction, where you're just moving workloads around, but on-prem is one of the target places where you can put a workload and work with that easy abstraction. So that's actually quite wonderful for me. And I think the last big point that I want to make is that all of this supports site reliability engineers. Site reliability engineers are people who are working, so site reliability engineering, let's just shorten it to SREs, or SRE is implementation of DevOps. It's Google's implementation of DevOps. It's got very specific responsibilities and tasks that are DevOps related, but then are also very much directly supported by Google's toolings, so that, you know, there's no ambiguity about where you do what. You do it on this console, you go and look at that console, and you have a full view of the whole software life cycle using the set of toolings. So site reliability engineering is a very interesting career path that I'm looking at myself. I'm about to go and write the DevOps exam for Google and be a qualified site reliability engineer. And I think Anthos speaks exactly to site reliability engineers who have complex installations that they need to manage, and it empowers them to make it look easy and really deliver on the asks of executives, you know, and leaders who are demanding more and more of their IT infrastructure. So, without further ado, we really want to actually show you stuff. That was my whole sell part. Want to show you stuff. And we want to show it to you in the context of a story of a company, not unlike Annette's Flexiforce. But this one is called Amazing Widgets. It's also walking a similar journey to hers. Sorry about that. Let me actually just read out what we wrote about Amazing Widgets. Amazing Widgets started a couple of years ago. They sell access to an API that performs product comparisons across multiple vendors. Their solution started out as a small offering to a local e-commerce company. However, recently it gained huge traction from international companies, and now they're rapidly expanding into new regions and new product ranges. Amazing Widgets developed an algorithm that can make comparisons far quicker across more products and in a fraction of the time that their competitors can. When Amazing Widgets started out, they all served all customer requests from a single VM running their application, the API and front end on separate machines running, and on a separate machine, they're running an SQL database. The founder of the company, John, let's make it Janet, is the sole developer and server engineer. With rapid expansion into a global market, the single server quickly becomes unstable. Users from faraway areas complained about latency. Sometimes a code update to one area would result in breaks somewhere else. So Amazing Widget has hired 5 developers to work on expanding the current code base with a team of 3 infrastructure engineers who would oversee running of the platform. One of those infrastructure engineers is Julian, and he's a site reliability engineer, and he's here to show you what he's going to do for Amazing Widgets as they take their journey further. But if I can, this is what Julian is going to show you. These are the 3 big things that Julian is going to wow you with. He's going to show you that it is actually quite easy to move from an on-prem server that maybe that you've got a VMware running on-prem. Take that and move it into the cloud. That has become easy. And I know it's a stumbling block for a lot of people. They're like, oh, how do I modernize? Do I have to hire some super smart guy to turn this into containers? Actually, Google solve it for you. It's really quite easy. Julian's going to show you how. As well, Julian is going to wow you with showing you that we have, and there's a shout out to iOCO here, another one of our partners. iOCO availed a VMware installation they have sitting in Cape Town. Julian's going to show you that through this GCP console for Anthos, he's going to be able to deploy workloads into Cape Town. My mind is blown just saying it. And then finally, Julian is going to show you that you will be able to see everything. There'll be observability of your entire infrastructure, multiple Kubernetes installations, as many as you like. And perhaps he might show you how one might troubleshoot issues in such an environment. Not sure if we included that in there. But without further ado, Julian, wow them.
Thanks, Sizwe. How's it, guys? I'm just going to share my screen, great. Cool. Can I run through a little bit of backstory, and then we'll kick it off with the technical demos, see how we are for time. Okay, so this is going to be a super quick demo, a quick talk through. The focus is primarily going to be on Google Anthos as a modernization platform to catalyze cloud-native awesomeness. So, subtitled The Amazing Widget Story, and just shout outs to DigiCloud, iOCO Cloud Services, and Google as partners and for helping out with getting everything ready for the demo. Cool. So just to set the scene around the Amazing Widgets journey, They began in the garage, like pretty much every other great startup story. And everything was going kind of as you'd expect. And then all of a sudden, the demand for widgets just exploded. Or pricing of widgets. I don't know what a widget is. And that was awesome for their revenue and bottom line, but it was a major issue from a technical perspective because they had been running a fairly monolithic, standardized, and primarily manually managed backend infrastructure where all of their APIs terminated. So scaling to meet this new growth was proved to be a very stressful and terrifying exercise, as we can see. But fear not, Amazing Widgets, because a hero has emerged in the cloud native space. And with Anthos, Amazing Widgets has been able to leverage a multitude of capabilities that would otherwise have taken a lot of time, effort, and money to engineer. And kind of with the click of a button, a lot of this has allowed them to scale, orchestrate, truly hybridize, but more so leverage kind of capabilities in the cloud native sphere that are really only starting to be adopted by enterprises now. Things like service mesh and binary authorization. We're going to run through that journey and the different components and capabilities that Anthos has unveiled and is now able to be leveraged by really anyone, Amazing Widgets notwithstanding. So their journey to cloud native awesomeness went kind of like this. First and foremost, they had to start with containerizing their archaic and fairly non-portable, non-scalable legacy backend service, and they leveraged Migrate for Anthos to do that, which allowed for a lot more portability. With that portability, they had the capability of deploying their services to customer environments, landing them in different geographies, basically exposing them geography per geography, and that was enabled through the Anthos GK on-prem, which is an on-prem Kubernetes platform, but more than just Kubernetes, as Sizwe was alluding to. It is literally bringing a lot of the Google Cloud and Google Data Center capability to your data center or to your customer's data center. With a containerized API layer and a on-prem deployment of Kubernetes, the power of Kubernetes orchestration and auto-scaling was leveraged to address their inability to scale to meet actual demands, lots of requests coming through, not being able to actually automatically scale to cater to that. So auto-scaling was quite easy to turn on, and we'll run through that as part of the demo. Step 4 through another few steps were kind of happening bimodally in the background, and what that was really focused on was actually the application modernization, which is, I think, a real important piece to this whole story. But in the background, the devs were busy working on modernizing and decomposing the old monolithic API services into more portable and independently scalable, independently deployable microservices. With those in hand and a whole bunch of new cloud native features such as service mesh, they gained full visibility and insight into their microservices workloads, requests traveling through the various services, processing times, and importantly, things like service level objectives could be surfaced and raised. And if there was a poor performing service or a new deployment that might have added a regression, it could quickly be tracked and traced. So we're going to run through pretty much all of these from beginning to end, starting with how we can actually take a legacy traditional native virtual machine running our API service and containerize it without having to, engineer anything other than essentially just pointing Migrate for Anthos to our workload. So in order to do that, I've actually kind of taken a video of that process, just given that it takes a little while. It takes about 10, 20 minutes, depending on the size of the virtual machine. But before we kick that off, I'll just give everyone a bit of a view as to what that looks like. So I just need to flip through this here. Yeah. So here's our virtual machine. It's running our backend service, and we could have any number of them running behind a load balancer, but ultimately it just breaks portability and doesn't really allow us to move quickly and to deploy anywhere. So we've got a virtual machine with public IP address, and here's our old monolithic backend service with our various API endpoints that we could call and get our products and pricing, which is great. But the issue being that, this is prone to error, and we can't really scale it, independently and nicely. So Q, Migrate for Anthos. Now, in this demo, we are using a Google Cloud VM, but I do want to point out that you can use Migrate for Anthos on traditional vSphere virtual machines as well. So you can convert your on-prem workloads, native virtual machines, into Docker containers and then deploy them, into GKE on-prem or any Kubernetes workload, or just run them natively as Docker containers if that's your thing. So just to kick this off, the first thing we'll do is actually run through that migration process. So I sped this up just to, save time. But here you can see I'm creating a migration, migrating a backend service, and I'm just going to pause there quick. I'm giving it the virtual machine ID of the VM that we're going to be converting into a container. Just pause there. The migration intent essentially allows you to either specify an image or data, or image and data. If you need to containerize or migrate a stateful workload, something that's got data tailored to it, then you'd likely want to take the data with you. But obviously that's all up for, that would just take some due diligence. But for our purposes, we're going to be moving our backend API service, which is effectively stateless. And we've kicked off the migration plan generation. So that is step one. Okay, once we've got our migration plan, we can actually go and step through it and see what it entails. So this is generated by Migrate for Anthos. We're going to pause to let it buffer up a bit, so it's a little bit blurry on my side. There we go. And here you can actually see that it's going to create two images for us. A base image, which is essentially just a source image that if you need to change or update or want to make any changes, that's the image you could essentially incorporate or rebuild into. And our runnable image, which is our amazing widgets backend with the API that will be baked in through some incredible magic that actually allows all of the running services in the virtual machine, kind of regardless of what they are, to be exposed through the container. Carry on with that. You can create little policies or extend or modify the migration plan just to specify how you might want it to actually be actioned, which could mean excluding paths in your virtual machine or potentially making additions for that matter if you need to. Okay, and that will kick off the actual migration process. So the migration plan was created, and now what's going to happen in the background is a virtual machine, well, the virtual machine will essentially be scanned and converted and built into a Docker container. Now, what you're not seeing is the actual plumbing in the background. There is actually a processing Kubernetes cluster that has a bunch of CRDs installed for Migrate for Anthos that facilitates all of this. So it actually deploys as a custom resource definition in GKE or GKE on-prem. So if you want to migrate vSphere virtual machines and have a localized kind of ring allowing you to just convert them and deploy them directly without leaving your data center, you can do that. You can use a GKE on-prem cluster as the processing cluster. So here we can see after about 10 minutes or so for this service specifically, we've got a new image that's been created along with a whole bunch of artifacts. And I just want to pause there. So these artifacts will essentially allow you to run a deployment straight into a target Kubernetes environment. But importantly, the image that we've got has been pushed into the container, the Google GCP container registry. And we'll actually go and see that the image of our virtual machine, the container image, is now available to us within the container registry. So now we have a container image that's been migrated from our old legacy virtual machine. And what we want to do is localize it to a data center where our customers will be calling it, or one of our various consumers will be calling it. So that's where we're going to leave off from the recorded videos and into the actual technical demo. So as you can see within Google Cloud Platform, we've got an Anthos portal page here. And I just want to quickly run through how it's set up. We've got a GKE on-prem Anthos and a staging cluster where our develop and production artifact, or develop and test artifacts, will be deployed to, but we'll get into that a bit later. So this is a cluster that's running within iOCO Cloud, running on vSphere. These are the various nodes that it comprises of. And we're using the bundled Seesaw load balancer, which is a Google engineered load balancer, which integrates really nicely with Kubernetes. It allows us to do things on-prem that a lot of kind of typical Kubernetes on-prem distributions don't really cater to, such as creating load balancers as you would in a cloud environment that actually go and provision with integration a new load balancer, a new front end for you on your edge load balancer. The way Anthos is deployed is you create an admin cluster, and that has a control plane and user clusters or working clusters as such. And you can have as many working clusters. Well, I think there's a scale limit, but essentially your admin clusters will have all of the orchestration, management plane, tooling, monitoring deployed inside of them. And your user clusters is essentially where your actual running microservices or containerized workloads will be deployed to. We're working in our prod cluster here. And it has its own control plane. So you can get nice multi-tenancy if you are an enterprise by deploying multiple user clusters for the various business units or consumers and driving strong isolation. So with that, what we're going to do is now deploy our containerized API service into our Google Anthos GKE on-prem Kubernetes cluster. So one of the powerful things I think is that you can manage your on-prem clusters, on-prem Anthos clusters, as we have this one, just as you would a typical GKE cluster. So it's pretty much driven directly through GCP as a single pane of glass, which is really handy. I mean, if you are trying to hybridize your data center, this really enables that in a very quick and seamless way. And to illustrate that point, I'm going to deploy that image that's sitting in our container registry from the the Migrate for Anthos conversion into our GKE on-prem environment. And I'm going to just pick the amazing widgets SRV01 image that was generated by Migrate for Anthos last night. And we'll just give it an application name. So, and a namespace that it will deploy the image into. So that's the working enclave within our GKE on-prem Kubernetes environment. and we can go deploy. Now, because this is a migrated image, I do need to modify our deployment slightly to cater to the migrated image itself, which is not a problem. You could actually just download the migration artifact and apply it, but I wanted to show the click-through deployments just to show how simple and easy it was to migrate a virtual machine and then deploy it straight into our on-prem environment. So I'm just going to actually apply a little bit of YAML to our migrated deployment here, just so that it knows how to mount the various things that a migrated image might require. And we'll just save that. And what we should have is a new image being deployed. We can drill into it, and we could even have a look at what it's logging out as it's running. We can see our services starting up. So these are the logs that are actually being generated by the container. So as you can see, some of these are kind of, similar to what you would see when you start up kind of a machine or a Linux machine. But we can also see our backend API services being started as well. So this is a pod now running in our GK on-prem environment. We're actually watching the logs in GCP in real time. So that's really handy. Here you can see we've got our amazing widgets service running, and we'll have a single replica of it. Let's just double check that. Okay. So what I'm going to do is just remove our autoscaler for the sake of a demo, virtualize, and just scale it down to single instance. I'll run everyone through how you can attain auto scaling in your data center on premise from a migrated workload with clicks of a few buttons. So I've just done that. When you do deploy a service from within the GKE portal, it automatically creates an autoscaler, and I want to manually create one with you guys. We'll just wait for these pods to terminate. So we have a single instance running, and what we're going to do is fire off a few requests using a load generator that should cause enough activity to actually trigger a scale-out action. Before we do that, I'm just going to add a load balancer service to our recently deployed backend API pod. I'm just going to give it a porture. Wait for this. Now, because I'm not using DHCP assigned addresses, I might just need to go in and plug in a address manually quick. Won't take a sec. So what I'm going to do, as you can see, is it's complaining about the load balancer IP. I'm just going to give it one manually for now. And I've got one reserved on hand. And what we should actually see is our load balancer address. If we jump over to our integrated Seesaw edge load balancer, which is fronting our user cluster and all its traffic, we'll actually see that in fairly, I might have to just refresh this. Let's jump away. There we go. So there's our load balancer address that's just been raised on our edge load balancer automatically. If we had a DHCP server in this environment, it would be even more automatic. And in theory now, if I hit this endpoint, we can go to our docs. So, I mean, that's pretty powerful. What we've just done is taken a traditional virtual machine running a backend service, whatever it might be, and we have migrated it using Migrate for Anthos to a container, which has pushed it into a registry. We've then deployed that image that we've created into our GKE on-prem, our on-prem Kubernetes environment, running in our Kubernetes and our vSphere cluster on GKE on-prem, and exposed it. And now we should have pretty much parity with our virtual machine environment, and we do. And I know this because I came up with these product names like Automatic Fuzz Ingester. I don't know what a widget is, you guys. Cool. So that's done. Now, what we want to use is auto scaling within Kubernetes to be able to address fluctuating volumes of traffic, surge demands, etc. And what we're going to do before we even spin up our load balancer, our load generator, is I'm just going to put in some auto scaling metrics specifically around CPU, but you could even plug this into something external like a Prometheus if you wanted to. You can tie it into an ingress controller and scale based on requests. We're just going to use CPU-based auto scaling for now to keep things fairly simple. Also, I know how CPU hungry this service is because I wrote it. It normally takes about a minute for the metrics to pass, about a minute of polling so that the HPA gets a good feel for where we're at in terms of current CPU utilization. So while we're waiting for that to just move through, we'll jump over to our load generator, which is running in the same cluster in a separate namespace, and essentially is there to just fire requests at our recently containerized monolith, which is what it is. It's got all our APIs in one. Let's see if we pick up our, there we go, 14%, great. Now I'm going to scale up a single instance of our widgets buster, which is just going to fire a whole bunch of async requests to the various API endpoints. When I say a whole bunch, I mean a whole bunch. That'll be starting up, and once it's up and running, there we go. We should see in fairly quick succession, these are the requests flying through, and if we jump back to our actual backend service, we should actually see it scaling relatively quickly. We should see new pods getting added here probably within the next few seconds. So we've now addressed our scale out requirements without really having to do much. It's adding in a second pod to deal with the load generation. We can actually just go in and see where we're at in terms of our CPU consumption. So we're hitting 58% or 30% against the HPA, which means that we'll probably hit the third pod within the next few seconds or so, but we don't have to wait and wait. There you go. So we're scaling out to 3, which means we've hit the upper bound over HPA. Obviously, we could scale out more. But this basically allows us to dynamically address incoming requests without having to create a new virtual machine, update a load balancer with a new backend pool, make sure that our application is properly deployed and configured there. It's all done very seamlessly. And if you think about the span it's taken to do all of this, literally a few minutes of this demo, and we've, containerized, well, we're about to hybridize, and we'll get into that now. We've containerized, we've deployed into our localized data center, we've exposed the service, and we are now auto scaling already. So that's very, very powerful. A few of the other points that I think are incredibly, beneficial and really easy to just get into are things like our error logging, which becomes immediately available to you through, things like Stackdriver within Google Cloud. There's a Stackdriver logger that you deploy within Anthos, within GKE on-prem, that allows you to actually see traces and errors as they crop up, and they get classified, pretty much as they get picked up. So here we can see that one of the pods in our Anthos environment has actually hit a timeout, meaning that when I run a load gen against it, we can actually see that it's not able to cater to the load, and some of the requests to it are timing out. So that's quite powerful. We can also get a very nice cluster view. You can quite quickly and easily deploy the very traditional Prometheus and Grafana stack. It gets deployed through, Anthos as a, additional stack on your user cluster, and a whole bunch of de facto dashboards get created. But you can also use the GCP cloud monitoring to get a view as to what your environment is doing at any given point in time. So here we can see, I've made this dashboard a little bit too messy at the moment. I should be doing some more filtering. But here we can see a whole bunch of different pods in our GK on-prem cluster, what network throughput looks like. We can see the containers, starting to spike. And that's probably from the load gen that we're running at the moment. The last thing that I think really kind of ties it all together quite nicely is the built-in event stack. So outside of just error detection, we can go and compose a whole bunch of log-based metrics if we wanted to for events that are going to be coming through from our pods. So if I wanted to just track down that timeout, I could create a query and then just say, show me all the pods that are having timeouts over a time period. And if we drill that down to maybe the last few minutes or so, here we can see, okay, there's definitely something happening here. Timeouts are being caused by something somewhere, and we could drill into that and get a nice quick view as to where those are originating from, and then potentially drill into why those are happening. So from an observability perspective, there's almost nothing that you need to do other than just plug in a few queries potentially. Even into more business type metrics. So if I want to see how many products are being created, whoops, let's just flip to prices. There we go. Just gonna jump back and forward. So if I wanted to see from our load generator, which is also going to be adding new products and testing, almost like a bit of an integration, bit of fuzzing, we can actually go and see the various events that happen where products are being added to the amazing widgets backend, which is quite nice. You could create pretty great, almost BI level dashboards here from these types of events as they're occurring throughout your system. Okay, so that was points 1 through 3. Then all of the developers went not home. Well, I guess they did go home, but they went to the battlefield and took our monolithic backend API, which, as we can see, actually works fine in a kind of containerized environment, and is also benefiting from the portability and the scalability that we can get from things like Kubernetes as an orchestration substrate, and GK on-prem, and the various primitives we've got here that allow us to actually gain more observability and insight into it without really doing much on top of it. But we have deconstructed that monolithic environment into a microservices environment. So using the cloud source repositories here, we've taken what was essentially a monolith and broken it up into 3 distinct microservices to retrieve products and suppliers and then do price comparisons. These have been plugged into our cloud build, and we are now using a much more CI/CD focused delivery mechanism, which will deploy into a staging environment where we can run, various layers of testing, whether it's, just functional, UX, UI, or performance, before we bring it into our production environment. And our production environment is running on our on-prem Anthos. So we've got a development / test pre-prod cluster sitting inside of GKE. And when we're ready to do the production deployments, we can just push images down to our localized in-data center cluster, which is a really nice pattern. And you could reverse it the other way. You could have multiple in-data center clusters. It doesn't matter. We've just picked this as a pattern. Now, what we're hoping to do is use another Anthos capability, which is service mesh. And as you'll see, there's quite a few different plugin features that are available through Anthos. So things like being able to define policies around authorizing which containers are allowed to run on your cluster, doing things like attestation and image signing, through to config management. There's quite a lot of additional functionality that we're not even going to touch because it's pretty broad. But the service mesh capability is very powerful. So Anthos Service Mesh is based on Istio, and it comes with its own cloud tooling. If you want to get into the technical weeds, I've committed to not even showing a console for this demo, which is kind of difficult for me, to be honest. But I do have to jump into an IDE to break this app. So what we're looking at here is our staging stack, or kind of our test environment for amazing widgets. And we've got our 3 different microservices running, and they'll be receiving a whole bunch of requests currently through our test harness. And if we jump into a single one of them, we should be able to get a pretty great view out the gate as to what its performance profile looks like. And the longer you run it through, the longer you have your services running, the more holistic idea you're going to get as to what the good upper and lower bounds are for it in terms of its performance profile. But we have defined a service level objective on this service, which we can actually trigger alerts on to let the development team, the operational team, doesn't matter, know when potentially a regression or degradation has been inadvertently introduced through bad code, or just a feature that might be underperforming. And that'll allow us to take action, potentially do a rollback, or ideally, before it even gets to our live production environments, we should be able to intervene. And so this is when we get into the real technical weeds. So as you can see here, we've got an SLO that's been defined, and it automatically will calculate an error budget for the objective that we've got set. So we want 20% latency against a kind of rolling average, as you can see here. If we go and look at the metrics themselves, for this particular pricing service, which does call on which calls on the actual remaining other two services, we can get an idea as to what its current request rate looks like and what the errors are that are being generated through, potential 500s that are being triggered. One neat thing is if you just flip right over to the dashboard, you should actually be able to get a quick view as to errors that you've got tied in through service mesh, for example. So here we can actually see this happening pretty much immediately. As our staging environment is being run, it's automatically picking up, classifying things like stack traces, and we can go and jump in and drill down into where those are happening throughout our environment. So pretty powerful stuff without even really needing to do much other than turn on the service mesh piece for Ansible. Importantly, because what we're going to try and do, because I've managed to get this right a few times, but sometimes it takes a little while to error out, is we're going to try and introduce a regression or a defect, which will automatically be deployed to our staging environment. And it should be picked up by our service mesh, which obviously is getting all this telemetry through proxies or sidecars that get injected into our running pods. And we should see the latency spike up. We should see it. One of the, while we're kind of looking at the various things that we get surfaced through our service mesh kind of view here, is you'll be able to actually go, we've got a fairly small microservice, but you'll be able to go and drill into the different inter-service communication. So here you can see our pricing stage. Our pricing service communicates outbound to its two kind of sibling services in a more east-west way. And the service mesh is actually doing mutual TLS between all the services. So that's east-west traffic communication, which you'll typically, it's quite complicated to do this outside of a well-orchestrated environment where you've got certificates that need to be rotated, etc. With service mesh, the proxy actually offloads TLS between other proxies. So we're actually communicating securely in an east-west fashion here. We can also see that the number of upstream systems, how many requests our pricing service is making to them, what the specific error rate is, and the latency, etc. The last thing that I think is really cool are some of the beta features that are coming out with Service Mesh. So you get some pretty great profiling. Obviously, we need to have potentially a little bit longer time for this to run, but you get some really phenomenal profiling per service with kind of error breakdowns, etc. as well. So really cool. So jumping back into our service health here, what we'll do is just get a nice holistic view, maybe just jump into the topology view for all services. I don't think that's going to show us the SLOs though. And here you can kind of see from a topology perspective, the pricing service is responsible for communicating with the two downstreams. So it's almost kind of the point of ingress for them. And you can kind of also just drill down and get a view into the amount of transactions per second that are hitting our downstreams, or technically our sibling services. So, interesting part, the real cloud native test of Meetup is we'll commit we'll run a new commit to our cloud source repository, which will trigger a cloud build, which is going to build us a new image, and it's going to deploy it into our staging environment, and we should be able to watch our staging environments, get the new pricing service. And the last thing we should do as part of this demo is pick up, hopefully, that we've introduced so much latency that we'll cause an SLO to trigger and say that we're reached our error budget. So great. Well, actually, let's give it a real sleep. Break stuff. And that's been pushed up. You can jump over to cloud builds, and we should see a new build being triggered. And there it kicks off. So cloud build is YAML based, and it lets you scaffold very quick. Lets you scaffold CI workflows, CI/CD workflows very quickly and easily. Everything happens inside of a container, which means that you can just pull down whatever you might need from a container perspective as part of your CI process. So here you can see that we're building our Docker image, which is based on fast, apply some logic to how we actually tag these images. This is getting pushed into our container registry. Wait for that to go through. And there we can see the deployment running. This should finish all green. If we jump down to our pricing service, which is here, you can see we've had a pretty great solid run of builds. Just to illustrate, if we jump into our microservices repository and into our pricing service, we can see that there are a whole bunch of images. Some are being tagged as master for production and some as developed for staging. This is just being pushed in, and this will be deployed through CloudBuild into our staging environment for testing. Here we can see that we've got a new pod being deployed. We're just waiting for its readiness probe to give it the all clear, and then it'll take traffic. Now we know that we've actually introduced a defect into this. So what we should see within a minute or two is our latency should start to spike from service mesh side. And that'll allow us to potentially jump in and intervene, either rolling back and staging or committing a new fix that will automatically roll out, which we can then monitor and address or correct whatever we need to. We just look at metrics for now, wait for this to finish deploying. And it's running. You can actually see that it's already starting to spike up in terms of processing time, because we've added in a sleep, which is going to cause it to pause 5 seconds for every request that it gets for that one API endpoint that it's exposing. Wait for this to load. Okay, we should be up and running. Let's just go back to running, but potentially not healthy. Just waiting for the old pod to terminate. For some reason, it's just taken a little longer than it usually does. Okay, well, it is running. Let's just wait and see what happens from a latency perspective. As you can see, the errors have shot up and we've got latency starting to climb. We can actually maybe just drop our timeline to the last, few minutes, and we should see it pick up. I don't know if it's going to pick up in time for us to get the alert. I'm just cognizant of time, but what we should see is our SLO being triggered as the latency climbs past our defined SLO, rolling average really, and we break our error budgets. The health indicator should actually start to fire, and that will result in a notification to me to go and fix my bad code. But I don't think we need to sit and watch and wait for this to happen. The sentiment is there.